Okay guys, this video is on asymmetric key encryption. Yesterday we did symmetric key encryption and we only had one key. Today we use asymmetric key encryption where we're going to have two keys. So here's the deal. Bob wants to send a message to Ann and this message needs to be encrypted. So Ann creates a public and a private key. She then sends the public key to Bob. Bob will use this public key to encrypt the data. Ann will then use the private key to decrypt the data. No one cares who has the public key. It's only used to encrypt the data, but Ann keeps the private key to herself and she uses it to decrypt the data. Now don't forget to use these same values. A is 1, B is 2, C is 3, and so forth. Okay. So this is called the RSA encryption. And we start out by creating two very large prime numbers. We're going to call these two numbers P and Q. In our example, P is 11 and Q is 3. In the real world, these numbers would be maybe 300 columns wide. They would be very, 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 very large. But for us to teach the concept, we're going to use something simple. P is 11 and Q is 3. Now, we need to create some private keys. We'll call the private keys B and N, and we have to create some public keys. We'll call them A and N. They are mathematically related. The first thing I want to create is N. Okay, and N is real simple. It's just equal to P 11 times Q, or 33. Now, A is such that it must be relatively prime to whatever P minus 1 is, 11 minus 1 is 10, times Q minus 1, 3 minus 1 is 2, 10 times 2 is 20. A is such that it must be prime to 20. Now, this could be a lot of values, right? It could be 3, could be 5, 7, 9, 11, 13, 17, and 19. They're all relatively prime to 20. The computer will randomly generate one of these. It'll randomly select one of these, and let's suppose it selects 7. So now we know that N is 33, and we've calculated A to be 7. B is such that A times B, 7 times something mod 11 minus 1 times 3 minus 1, mod 20 needs to be 1. So if A is 7, 7 times what mod 20 needs to be 1? Well, 7 times 1 is 7 mod 20, that's 7. 7 times 2 is 14 mod 20, that's 14. 7 times 3 is 21 mod 20, that's 1. Let's make B 3. Now we have our values. So we know that A is 7 and N is 33. B will be 3 and N will be 33. We're going to send A and N to Bob, and Ann will keep B and N. Bob will have 7 and 33 as his keys, and Ann will have 3 and 33 as her keys. Now it's time to encrypt.